Hi, my name is Tony Shahidi from IPM, Integrated Programming and Manufacturing. And what we're doing right now, we're going to follow up on the last session we had. Last session, what we did, we had to create some geometry, additional geometry to the cylinder port in order to create the vectors and create a spline in the middle. You can use a Mastercam automatic spline. It mostly works, but the only problem here is this part has a little tweak inside of it. It makes it a lot more complicated because the tool has to clear the bump in the middle, and you shouldn't hit the top. So it makes it a little more complicated than automatic spline creation. So what we did, I'm going to turn some levels on. Okay, and go here, try to fit the screen, and we're going to go a little to the left. Okay, so what we did last time, we created a curve on both ends of this port, right on top of the lip, on the flange, outside flange, right there. So you create curve only on one edge, and then sometimes you have to. There's going to be a bunch of little segments here. Sometimes you have to chain and watch out for smaller portions. Keep chaining it around till you finally finish the chain and close the chain. So by doing that, you basically you're giving yourself something to work with. You cannot create another surface like this surface or vector without having a curve first. So you create a curve here, and you check mark OK, gives you the curve, and then put them on a separate level. So create a level for curves, for example, and then you go back over here again on the second side of the port, and it's got to be a larger flange, and you do the same thing again. Create a curve only on one edge. You chain this around, make sure you don't miss any small lines, and then OK that. Then you have curve top on the bottom and curve on top. So next thing we did was creating a flat boundaries on both ends, and that's create flat boundary. So create surface flat boundary. So what happened here? We created a flat boundary on top of this port and also this end of this port. In order to create our vectors, we're going to have these surfaces and also the curves. Next thing we did, basically, we went out there and created vectors, 800 thousandths long each, and then we created blended spline. I'm going to take the shading off, go to wireframe. Okay, so this is the vector 1, 800 thousandths, and this is a vector 2, 800 thousandths, and this is a blended spline, which is created in between these two vectors and from the surfaces to surfaces. And you can control this, the center of this spline. When you go create spline, it's going to be a small window on the left here, which controls the curve. The reason why I'm saying that, another thing you should keep in mind, you must always keep your vectors, so don't delete them, even if you don't need them. Put them on a separate level and always save them. The reason why I'm saying that, because sometimes when your toolpath, the lollipop, follows the spline in the middle, and it violates top and the bottom. Maybe hit the bump or hit the top surface inside the port, or it might alarm out. So sometimes you don't get lucky in the first shot. So if that happens, I would delete the spline first. I'll try to recreate it and go to that little section right there and change your control of your spline. Over here, the curve, it goes up and down a little bit at a time. Or another thing, if that don't work, still you have an alarm, what you have to do, you have to delete the spline, both vectors, and recreate the vectors. And when you create the vectors, and then you gotta stay up in front, in the center. You move a little bit to the right, a little bit to the left. You do the same thing here, and you create a spline, blend it. You try toolpaths again. If it's good, you keep it. If it's not, then you might have to go back, do the whole thing all over again. Create a vector here, move it a little bit to the other side. You keep doing that till it comes out the way you want it. Sometimes you get lucky first shot, but it's just one of those things, So basically, geometry right now is ready, and all we have to do right now is to program a part. The part's already programmed, so what I'm going to do, I want to walk you through it. it might be more than a one session. I gotta keep my videos under 10 minutes in order to load it up, upload it. So bear with me, and it's gonna be fun, okay? So let's turn the surface back on, and then let's remove the ends. Okay, so now we have only the cylinder port, nothing else attached to it. As you can see, if I move it around, right there. Another thing I was going to tell you, right now I'm using a regular mouse, but when I'm really actually programming a part, I try to use my 3D connection, and it's a space mouse, and it's amazing actually. You know, it's the way it works. I can probably show it to you right now. Let's go here, fit the screen. Okay. Okay, so bear with me. Okay, so this is the 3D connection mouse. It's a space mouse, it's wireless, and right now it's charging. When it's charged, usually you can see a bunch of blue lights around. It's really nice. But I use 3D connection mouse because I use it with SolidWorks. It has options for SolidWorks already built in there, and also for Pro E, and also I use it for Mastercam for smoother rotations. And the reason why I'm saying that, regular mouse, if you're doing a complex part, 5-axis has a lot of surfaces, a lot of different, elements attached to it, then you might want to consider spending like $100 some and get the wireless 3D connection, 3D connection. It's going to make your life so much easier, very smooth and very predictable, not like a regular mouse. So all you have to do is you just move that around a little bit, and then basically you get your, right now it's not hooked up, but so you move that thing around and your parts will move around at the same time. So this is just a input for you. This is my best friend. I use the regular mouse, wireless on the right side, and I use this 3D connection mouse, wireless on the left side, and I use both of them as I'm working. Okay, so I'm going to end this video about another couple of minutes, and I'm going to restart again. Okay. Now, going back to the roughing. So the first thing we're going to do when we come back, we're going to go to Rough Toolpath. And Rough Toolpath, I'm going to demonstrate to you the options they have in a Mastercam and everything else, and what we do with all these options here to make it nice rough pass. And then I'll also show you how to do it from both ends. Since the 5-axis machine, you don't have to worry about both ends, because as long as your fixture is good, you can rotate it anywhere you want it. In 4-axis, you can't do that, unfortunately. And horizontals, you definitely cannot do that. Okay, so I'm going to come back. I'm going to go through the toolpath type, through the tools, then we're going to go through cut parameters, we're going to go tool axis control, and collision control. This is very important, and linking parameter. And after that, we're going to say OK, and we're going to see what the program looks like. Okay, so this is Tony Shahidi, IPM, Integrated Programming and Manufacturing, and I want to end this video right now, and we're going to come back in a couple of minutes. Stay with me.